Alright, today in lab we're going to test what a resistor is, how it works, and we're going to use it in a DMM circuit and compare it to specific values.
This is our transistor for our transistor gain lab, and it is a NPN transistor, and the collector's on this side, and then there's the base in the middle, and the emitter on the other end, and the max transistor gain of it is 300, with the minimum being between 34 and 100. So if we test the actual transistor gain using our DMM, we will get a measurement of 180, and there are no units on that because it's a ratio of current, so the units will just cancel out.
Today we're going to be talking about transistors. So we'll have Troy describe what the circuit would be like.
P transistor has a conductor, base, and emitter. Ow!
Troy, what was the phrase you said again for the first part of the
I'm sorry.
transistor?
I said conductor, it's a collector.
Good job. Okay, so this is the circuit that Troy described, and as he stated, this is a collector, not a conductor. And then we have the base, and then the current comes out of the emitter, and then here we have a LED to show that the current is coming through, and then we have a resistor to protect the circuit from getting too much current. And this works like a switch, so when the current comes through, it'll build up, and once it reaches a certain point, the current will all flow through, so it has a gain, and it can actually have more current coming out of the circuit than what was originally put into it.
Mr. Deeds, I have a question. How do we know this circuit's going to work?
Well, Troy, luckily we have an example here for you. See, here's the actual circuit, and here we have the LED, which is turned on because we have the circuit on, and that means current is going through it. And here's our transistor, and these are saying what we have going in and what we have going out. In this circuit, we have 0.12 milliamps going in to the collector, and then we have 27.2 milliamps going out. As you can see, that is a gain. So if we just punch them numbers in our calculator, and we do 27.2 divided by 0.12, we get 225.8333 repeating. That would be correct because in the data sheet it says that the transistor gain should be between 300 and 100. So Troy, now you know why our circuit works and how it works.
B, Professor, how do I know it's going to work? I don't think I'd ever use it again.
Troy, now what kind of attitude is that? I mean, you see transistors all over the place, but you don't even realize it. They can be used in things like switches, in things as switches. So once the circuit reaches a certain capacity, then it will start letting the current flow through the transistor and make things turn on like a light switch. So class, that concludes our lessons on transistors. And remember, current flows in the collector, sits in the base, and then comes out the emitter with a current gain. And then we have our LED that showed us that the circuit was running, and the resistor that protected the circuit from being overloaded.